we have a fully working Ubuntu environment with an LTS release and a good kernel on a $17 device that has Wi-Fi, that's got 40 GPIO pins, that draws nearly no power. This thing is just phenomenal. Welcome back, everyone. Today we are looking at the brand new Luckfox Lyra Zero W. This thing just came out last month and I love it. I think it's absolutely amazing. So we're going to dive into all the details about this. We're going to benchmark it. We're going to flash it with different images. We're going to plug it into some screens and see how it works. But first, I just want to let you know that this video is sponsored by Brilliant, who can help you become a better thinker. But more on them in a little bit. Time to get into this. So, looking at this up close, it is a very familiar Zero, as they call it, form factor. So it's essentially, I wouldn't say it's competing with the Raspberry Pi Zero, but I think it's a very, very good alternative, especially for how cheap it is. So we've got a 40-pin standard Pi 2 style header there. Now that's got, I think, 29 Rockchip Matrix I/O pins on it, so they can be multiplexed through pretty much every different function. That's because this has the RK3506B, which is a great little SoC. The SoC has 3 cores that are all ARM Cortex A7, so 32-bit, and it's the ARM V7 instruction set, or ARM HF. It also has the Cortex M0 in there as well. But it's a very low power, but very powerful little SoC. Next to that, we've then got 512 meg of RAM, which is just insane. We've got our wireless module there, that's 2.4 gigahertz, SD card slot. We've got USB pins there, like we've seen on the other Lyra. We've got our power and USB on the go. We've got a normal USB port there, MIPI CSI for display, an onboard antenna, an external antenna, and then we have 256 meg of SPI flash on the bottom. So this is a very dense, very powerful little device, and it's stupidly cheap. It's $17 US, and I have it in stock, of course. I also have 4 of these to give away. So Luckfox was nice enough that they decided to send me some extras. They sent me 5 extras. I'm keeping this one, but 4 of them I'm going to give away. So hang around and watch more of this video to see how you can get one of these for free, if you want one, that is. Going over to the Wiki. You can see here that the documentation is actually just a little bit lacking. It's such a new product that they haven't finished filling this out yet. If you jump up to the product introduction here, you can see the Lyra Ultra and Ultra W do also use this. So you get a little idea here. It's got the 512 meg, it's got Wi-Fi, it's got the MIPI CSI interface there, sorry, MIPI DSI. It's got your USB ports, 29 I/O pins. It doesn't have the embedded controller, it doesn't have the 8 gig eMMC. So I did do another video previously on these if you wanted to check it out, but this is the Lyra Zero W. So it's a little bit thinned out, as you would expect. Getting started with this is very easy now too. It's got a initial image flash onto the SPI flash that we can boot up. That has ADB, so all we really have to do is connect it using this port to the power on our computer, and we'll be able to connect to it. Let's have a look at how to do that. For this, I'm just going to grab a standard black USB Type-C cable, one end into there. The other end, I'm going to plug it into my computer over here, and you'll see very, very quickly, you've got this little heartbeat LED. So that does not take long to start. That's showing that it's basically loaded the kernel already. And in a few seconds, that's going to be at a desktop environment. Now, if we had configured Wi-Fi, we could SSH straight to it, but we're going to use the ADB shell that's built straight in. So jumping back over to the computer, which is here, you can see if we go ADB devices, it's listed there. So if we go ADB shell, we are straight in. Let's have a look. We have build root 2402. So that's the one that comes, that's the one that's in the SDK. And what else do we have? We have our 512 meg of RAM, no swap configured. We have our 256 meg of SPI flash. We have a 6.1 kernel, which is awesome. You can see here it's our ARM V7 instruction set. And I can't type. There we go. So there are our 3 cores. So this is a very, very capable little device for something that booted so quickly, and yeah, less than 12 seconds to be completely ready, essentially. It's $17, boots that quickly, that easy to connect, is actually quite amazing. What I'm curious though is how much power it consumes. So we can test that out by putting the FMB58 in the way. Now this is just going to be an initial, what's it consume off the bat sort of thing. In fact, I'm going to plug it in over on this side. It's not going to be whilst it's running anything too intense. We will do that later. I just want to see, to start with, what sort of power profile we're looking at for something that you can plug in, use instantly, and it's ready to go. Oh. So there we go. It's drawing stuff all. It peaked at 370 milliamps there, which you should have seen. So it did manage to draw a bit whilst it's doing something, but now it appears to have booted and it's idling around 128. If we jump back over to the computer, it's kicked us out. It hasn't picked it up yet. Oh yeah, of course, because it's not plugged in. This power cable goes up to my dedicated power supply, but that's stable at 130 milliamps now, running a Linux distribution, which really is really incredible. Now, if you are enjoying this content and if you like seeing this sort of thing, please don't forget to like and subscribe, because the algorithm is pretty harsh on YouTube, but every bit of engagement, whether it's the thumbs up, whether it's the subscribing to the channel, or just leaving a comment below, really, really helps. Now, this, as I said, is the initial image that it comes with. It's not necessarily the latest one from the SDK, so you can either download it or build it yourself. In this instance, I have built it myself, but if we have a look at where to download it, coming back over here, if we go to image flashing, you can see it does support Ubuntu and build root, but unfortunately the Ubuntu images are no longer available because they don't have approvals anymore. I'm not sure of the exact story, but you can click on the Google Drive link, which I've actually already got here, and you can download the Lyra Zero images. Now, there's no point putting that on an SD card when the flash is enough, unless you want more storage, but you can always mount that separately, I believe. So, downloading and extracting that flash zip file, you're left with a pile of files. So if we have a look at those extracted files that I've got here, let's go into here. You've got a couple. All the one that we're really going to need is that update.image. So we have this upgrade tool, and you can use this or arcade dev tool. The instructions are in here. So image flashing, here we go. You can see all the different platforms and how to flash it. Now I am using the update tool, which I have copies in here as well. So on my GitHub repo, I do put some of my own images up, and I will be putting another one up for this. But in the Linux folder, you can see I've got the upgrade tool and the arcade flash script if you want it to save downloading the whole SDK, because it does actually, unfortunately, say that you need to download the SDK to get it. But stuff that. If we go upgrade tool LD, we can't see it connected because it is still over here. I will grab this from there, plug it back into the computer. There we go. What I forgot that we need to do is hold down the boot button whilst we connect it. So that's going to put it in the mode where we can flash it with a new image. And I usually just hold it for 2 or 3 seconds. Once that's done, we can go back to the computer and we'll see that device is there. So if we do clear that, we can do upgrade tool, update firmware, and then we can specify this update.image. So now that's going to push that image straight onto the SPI flash, and it's going to reboot straight away afterwards. When it does, it's going to have the latest image there for us to use. Now, of course, you can also do an SD card image with it needs the Windows tool to do that. So I'm going to put an SD card image up for you that is a raw grab that you don't need to use SD disk tool for. You can use Balena, Etcher, or just the disks utility in Linux. If you are wanting to do that, I'd recommend coming and grabbing one of these. I've just got these in stock and started using them myself because of how damn good they are. There was a review here where this bloke kind of broke down every SD card and had a look at what they can do and how reliable they are. Go have a read of it if you want. But these are extremely cheap and extremely fast, so I got those. What you may also want, depending on what your Wi-Fi at home is like, is an external antenna for this. Now, that's what I've been using, but you don't have to. Now, to connect the antennas, you do want to be pretty careful. I recommend doing it because I have found this onboard antenna isn't too great. I'm not too sure what the reason is, but I've got this one here, and you just want to be a little bit gentle when you connect this little IPEX connector, because they can easily break off the board, and you probably don't want it powered on like I have here. Now, that's all flashed, and if we come back over here, we can see we've got our little blinking light on the computer as well. If we again go ADB shell, we are straight in. Now, I did say I had 4 of these to give away for free, and thank you to Luckfox for sending them. To do so, All you need to do is buy one with anything else from my shop and throw in the discount code. So having a look here, I'm going to grab one of these SD cards as well, because you'll probably want one too when you see what we've got coming up, and the antenna, and then we'll go to the Lyra Zero W, which is easily available on the homepage at the moment and marked down because it's new and awesome and I want everyone to have them. So once you've got the accessories in your cart along with your Lyra Zero W and you go checkout, all you have to do here is put in this Lyra Zero W discount code, and you can see it 100% discounts that. Then you just pay for the accessories plus shipping, and it'll arrive in your post box, your PO box, whatever you've got, in a couple of weeks. Probably, well, if you're in the US, a week or two, but I ship out of Australia, so it's subject to where you are. Now, as I said, this does technically support Ubuntu, but they have taken it out. I happen to have an older version of the SDK though, that still had Ubuntu in it, and so I have actually created an SD card image with Ubuntu for this, which was a little bit of work, but I think is absolutely worth it. Alrighty, so over here on the computer, if we just go ADB shell, the same as we did before, we're straight back in. And if we have a look at the release information, we can see we now have this 22.04.5 environment, which is a little bit more capable. We still have that same 6.1.99 kernel too, and you'll see that we do have the same resource consumption, and that is a tiny, tiny amount of RAM to be used. Now, a lot of people, of course, do want to join the Wi-Fi and use it that way. As I said, the external antenna really helps, but you do need to configure it too. So the first thing is configuring the network details in this configuration file. I'm using my nice secure Pi-Fi. And just so you know, all of this is actually in the documentation. If you go to the Lyra, you'll see there's a Wi-Fi and Bluetooth page here. For some reason, I've got the Chinese one, but it shows you what to do. So me showing you, we've modified that file. We're going to do kill all -9 WPA supplicant just to terminate that background process. And then we're going to run it again. So WPA supplicant -B for background, -I to specify the WLAN 0 interface, -C to then give it that config file. That takes a quick second, and we'll see that we have this interface up now, but it doesn't have an address. So you do also need to do DH client WLAN 0. Now, if you're still in the build root environment, the command you want to use is udhcpc -I WLAN 0. Back here though, we can see that is connected and we have internet. That is all you really need, because then you can start using apt to install things. One thing you might have issues with though is of course systemd and resolved. So I always just go name server 1.1.1.1 and make sure that works with a quick little ping of Google or something like that. So we have a fully working Ubuntu environment with an LTS release and a good kernel on a $17 device that has Wi-Fi, that's got 40 GPIO pins, that draws nearly no power. This thing is just phenomenal, but it still does more. And that's what I'm going to have a look at now and show you the last awesome part of this. Before I do that last bit, actually, I'm going to put a little heatsink on here, and I think we can give it a bit of a benchmark and see what it's doing. Again, you shouldn't put that heatsink on whilst it's running, but I'm dumb. What are you going to do? Back over on the computer, if we have a look over here, I can go apt install Python 3 NumPy and Python 3 psutil. We're going to need these for a little benchmark script that I've written. Back in my GitHub repo, if we have a look here, I've got one called ML Accelerator Benchmark. So I started putting these together a few months ago and I haven't been keeping it up to date, but it is actually pretty cool. The idea is to be able to benchmark small devices where Geekbench might not run. And I'm starting to store some results in here. You can see I actually ran this already a few days ago, but I'm going to show you how to run it now as well. To make it easy, I'm just going to grab the one Python file. We can see here we're going to need that one and we're going to need that one. I think most of the others should already be on here, but we will find out very shortly. So let's install those. Once they're installed, I'll download that Python file and we will get Geekbench going too. If you have a look at Geekbench preview, I'll just type that in. Version 5 supports 32-bit. Version 6 requires ARM Arch64, but this has the ARM HF or the ARM v7 version. So we'll test that out too. There we go. And now let's see if we're missing any extra dependencies. I'm hoping that's it though. No, look at that. Look at it go. All right, it just took a leap. I didn't actually expect it to get this far. It got up to 2048 by 2048, and it says it can go higher. So it leaves a little bit of a safety factor there, gives you a bit of background information. It'll do some warm-up runs, and then it's going to start absolutely hammering the matrix multiplication to see what the performance is like. I'll let this finish, and then we'll come back and we'll have a look at the results of this. Now, this isn't something I learnt in school though. Unfortunately, I had to teach myself, and that's why I'm thankful for today's sponsor, Brilliant. If you want to start learning to program in Python, which is consistently ranked as one of the most popular programming languages and has gained widespread use in machine learning and AI, then Brilliant's Programming with Python is the place to start and gives you hands-on experience with real programs and helps you to learn to think like a programmer. I started using Brilliant before they even offered this sponsorship when I wanted to sharpen my circuit design skills. And now my partner's using it too, although she's started with visual algebra. Brilliant helps you build your critical thinking skills through problem solving, not through memorizing. So whilst you're building real knowledge on specific topics, you're also becoming a better thinker. Whether on the computer or mobile, diving into a new course like programming in Python or doing a quick practice session of some algebra, Brilliant is the go-to platform to help you reach your learning goals. To try everything that Brilliant has to offer, free for a full 30 days, visit brilliant.org/platimatinkers or scan the QR code on the screen or just click the link in the description. You'll also get 20% off an annual premium subscription when you sign up. Brilliant, learn by doing. Coming back to these results, what we can see here is the theoretical power, the final number that we want to look at that we can compare to other things. There are some more details here if you really want to dive into it. But this one, which probably needs some commas in it, is the important one. So that's 169 million. Doesn't sound like much, but if we compare that to the ESP32P4 or an RP2350, we start to see some patterns here. So this one is at 1 million, and that's the ESP32P4, 1.8 million I should say. The MicroPython on the RP2350 was an amazing 8.3 million. And as you'd expect, we got just under 1 million in the results for the RP2040. And I included a quick breakdown of the math in this one too. So it is a very, very powerful device. And now we can get into the last thing that I want to do with this. And this is the cool bit. I want to put a display on it. This is the Waveshare 10.1 inch DSi display. I've got these in stock. I think they're about 80 Australian, so 50 US, but they are a great display. They're compatible with this out of the box, and so we can plug it in and see what happens. Let me just sort that out quickly. All right, that is all plugged in. I'm also going to plug in my USB receiver for the keyboard and mouse. Grab these over here and plug the power in. Now, there is an edge case to do with the power timings for this, and you can see I've hijacked the power straight from the board there, but nothing's happened. So I'm just going to hit reset, because sometimes the display hasn't initialized before it tries to output from what I can figure. We can see though, the display is instantly working, which is awesome. This is booting Ubuntu now because we still have that SD card in, but even if we didn't, it does the same thing with the build root environment as well. There we go, it's given us a little warning about the Wi-Fi, and we are there. So we can just go root, and we have our environment, much like we had before when I got Doom running on this as well. If you're curious, check out the recent video about the other Lyras, the Lyra Ultra that I tried out. Alrighty, over on the computer, we have our internet working now, and what's really cool is this gives us an option that you may not consider, and that's so we can just do apt install Xubuntu Desktop. So that's a meta package that's got XFCE, LightDM, and everything like that to get going with the graphical interface. Now this is a frame buffer interface. It doesn't have a GPU backing it, which means it is software driven and it is going to be slow, but it does give you a lot of options. Now you don't have to use, hit yes to start that going, you don't have to use that. If you have a look at the documentation here, they do actually have a bit about the Qt environment, and that's because Qt can output to the frame buffer interface. So any apps, like you can get web browsers, there's forks of web browsers, fork of Chromium I think, that outputs straight to the frame buffer, and that's how I did it with Doom. That though is downloading and installing. To skip the wait, I've got one I've already prepared earlier. So back over here, let's just pull that power straight out of there. We'll pop that SD card straight out of there, and we'll put my other one in that I already downloaded these files onto, and see something absolutely awesome. Boot back up, or not, hit the reboot button. Now we have our display. There we go. That is our XFC login prompt. So we have a $17 device with triple core, 512 meg of RAM, SPI flash, an SD card slot, 3 USB ports, 40 pin Pi 2 header that can power a 1280 by 800 DSi display. That is just amazing. Now this is also a touch display, as you can see. So if we put our password in here, we can log in with touch. As I said, it's still software driven. So this is going to be a laggy interface, but it gives you a lot of options. There is a lot of cool stuff you can do with something so cheap, so powerful, and so capable. I love this thing. I'm giving 4 of them away for free. If you want one, go and grab it. What I'm going to do after this is put the other SD card back in, download Geekbench, and we'll benchmark it there as well. So we have some comprehensive benchmark results of what this is actually capable of without anything running in the background, and I'll leave this heatsink on because it is doing it a little bit of a favor. Now lastly, I want to thank you for coming along and supporting this channel. If you didn't actually know though, I do have a Patreon. So starting at only $4 Australian, about $3 US a month, you can come along and support these videos. It would be greatly appreciated. There is behind the scenes stuff, there is early access with our adverts, there's chat, and I'll even give you a bit of support if you're playing with SBCs yourself. But thank you for watching this video, for liking, subscribing, and engaging if you have. Thank you to the Patreons, or my patrons, whatever you want to call them, for supporting this channel. Thank you to Brilliant for this new partnership opportunity. Don't forget that you get a free 30-day trial and 20% off a premium subscription at brilliant.org/platimatinkers to start your learning journey today. Thank you. And lastly, thank you, Luckfox. I hope you all learned something from this. I hope you're doing well. I look forward to hearing from you, and we'll see you in another week or two with some more cool hardware. Take it easy.